Differential and integral operations 4. Now we're going to work on part F, gradient of the product of two scalar functions fg is f gradient g plus g gradient f, and part G, gradient of a dot b is a cross product curl b plus b cross product curl a plus a dot del operator b plus b dot del operator a. So we're going to prove these two identities. So let's start with part F. We have we have to work on the gradient of the product of two functions fg, and now the gradient operator in del operator in subscript summation notation is del xi ei hat. This will be applied to the product fg, and that means we can apply the derivative to one of the functions first and then leave the second alone, and then apply to the second one and leave the first one alone. So first I'm going to take f out, f ei hat del g del xi plus, now I will leave g alone, g ei hat del f del xi. All right, and that means here I have ei hat del xi applied to g, that is f times gradient of the scalar function g, f gradient g, plus here I have g gradient of the scalar function f. So we reach the final conclusion. The gradient of the product of two functions, two scalar functions, f and g, this is equal to f. Let's just copy this result here. F gradient g plus g gradient f. So this is our final answer. So let's check if this was the identity we were supposed to prove. Part F, gradient of fg is f gradient g plus g gradient f. Now let's work on part G. Here we have the gradient of a dot product between two vectors, gradient of a dot product with B. So that means we have the del operator, del xi ei hat. This is going to be applied to the dot product. Vector A is aj ej hat. Dot product with vector B, which is bk ek hat. And ej hat dot ek hat is Kronecker delta jk. So that means I have del xi ei hat applied to aj bj, j components of a and b, because ej hat dot ek hat is Kronecker delta jk. All right, and now I can take the derivative of a, leave b alone, and then take the derivative of b and leave a alone. The same thing I did in part F. So this will be ei hat, or let's take this bj out. This is bj ei hat del aj del xi, and then we have let's make sure that this ei hat is outside. Ei hat bj del aj del xi plus ei hat aj del bj del xi. So what do I have here? Here I have the gradient of A, ei hat del xi, applied to the vector A, aj, ej hat, and that's multiplied with A. So I can write this as gradient operator applied to A only, gradient A dot B, plus here I take the gradient of vector B and leave A alone and then take the dot product. So this is a gradient operator applied to B only for A dot B. Okay. Now, remember from the previous problem in part E, we have shown that gradient with respect to B of A dot B is given by this identity. So now we can use this identity and basically note that here we have found gradient with respect to B of A dot B, this is from part A, is A cross curl B and plus A dot gradient operator applied to B. So this is from part E. And similarly, we could switch A and B. We would find that the gradient of A dot B, gradient operator applied to A only, is B cross curl A plus B dot del operator applied to A. So this is what we have seen in part E. So that's what we have proven. Now our answer is gradient with respect to A dot B, and gradient with respect to B, A dot B. So we can write our final answer using what we know from part E. The gradient of A dot B is, for gradient with respect to A dot B, I will substitute this result, B cross curl A plus B dot del operator A plus, for the gradient with respect to B of A dot B, I will substitute this result, and this will give me A cross curl B plus A dot gradient applied to B. So this is the answer we find. And let's check this answer. So we were supposed to prove this identity. gradient of A dot B is A cross curl B plus B cross curl A plus A dot gradient B plus B dot gradient A. So here's what we have found. B cross curl A plus A cross curl B, B dot gradient A plus A dot gradient B. So that's exactly what we have found. Okay, so we worked on gradient of the product of two functions, f and g. Del del xi ei hat applied to f and g. So we take the derivative of the second function, leave the first alone, plus the derivative of the first function, leave the second alone. And that gives us basically f times gradient g plus g times gradient f. As for the gradient of a dot b, we have a dot b is aj ej hat dot product with bk ek hat, and del operator is del del xi ei hat, and this is going to set the two indices j and k equal. So this is del del xi ei hat aj bj, and then we apply the derivative to aj only and leave b alone, and plus bj only, leave a alone. And here I have ei hat del del xi applied to aj ej hat basically, and so basically I find that this is bj ej hat, so ej hat dot ej hat is 1, so you can think of it that way. And this way I'm getting the gradient of gradient with respect to a. So for the jth component of a, dot product with b, so that's gradient with respect to a dot b, and similarly I have here gradient with respect to b, a dot b. So once again here I can think of this as bj ej hat. Let me clarify this one here. This is ei hat bj ej hat dot product with so let's write it here, bj ej hat dot product with del del xi ei hat applied to aj ej hat. So ej hat dot ej hat is 1. So this is only being applied to the vector a, not to vector b. So that's basically to clarify that. And here I have the gradient of vector a. So I'm taking the jth component because here I have a dot product with b. So this has to be the jth component. So for the gradient with respect to a and gradient with respect to b, I have the answer from part E. So I can substitute that here. So I find that gradient of the dot product a dot b is b cross curl a plus b dot gradient a plus a cross curl b plus a dot gradient b.